Nowadays, electricity has become essential in our lives. We use it in homes, communication, transport, and industries. But where does it come from? Fossil fuel power plants are the primary source of electric power production. Fossil fuels such as coal are burned to get steam, which then flows through turbines to generate electricity. But on the other hand, large amounts of dangerous gases are exhausted, and if not treated, the exhaust gases can have hazardous impacts on the planet, such as climate changes, acidic rains, and other health issues. That's why the world tends to use renewable energy sources, such as solar energy, geothermal energy, hydropower, and wind power to generate electricity. Installation capacity of wind farms has increased 30 times over the last decade. Various types of wind turbines are available in the market. Turbines are classified according to size, main driving force, and the orientation of the axis of rotation. Our target was to build a wind turbine that is light-weighted, can operate at low wind speeds, have a compact size, and comes at a low price. Among all the turbine types, Archimedes wind turbine was our best option. And now, we are going to see the whole story from start to finish, including all the working procedures and steps. The first step was the design process. Our mission in mechanical design of Archimedes turbine is to build a geometrical shape which is simple and 3D printable. But before going into the design process, some analytical considerations and aerodynamic constraints had to be given. So we collected data about the size, geometry, and material of the turbine from official technical papers. The design was made possible in a CAD software called SolidWorks by simply sweeping the blade profile along the fixed diameter helix and removing any extras of the blade by revolve cutting. 2 Archimedes turbines were constructed. The first one is a constant angle design, where the blade angle does not change along the axis of the turbine, while the other one is a variable angle design, where the blade angle changes along the axis of the turbine. To be able to make experimental operations on the wind turbine, we needed a test rig. The test rig consists of the turbine, a small variable speed induction motor, and a torque sensor connecting them all on one shaft. Building such a rig might seem as an easy task, but in practice, there are lots of factors that could make such a process a nightmare. Vibration, misalignment, mechanical friction, and unbalancing are the main fears to expect when building such a rig. Through a 5-month period of continuous work and problem solving, we were able to achieve a stable, balanced, adjustable and low vibrating test rig setup. To know how efficient the wind turbine is, an experimental study has to be made. There are 3 parameters that indicate the turbine performance. These parameters are the torque coefficient, the power coefficient, and the tip speed ratio. To calculate these parameters, we have to get accurate measurements of the wind speed, rotational speed of the wind turbine, and the torque developed by the turbine. After that, MATLAB and Excel are used to perform mathematical operations to get the required parameters. To visualize and simulate wind flow and its effects on the turbine, we used ANSYS software to perform a CFD study. CFD stands for Computational Fluid Dynamics and is used to validate experimental results without any additional costs. This process consists of three main parts: pre-processing, solving, and post-processing. In pre-processing, the geometry of the turbine, fluid domain construction, meshing and boundary conditions are installed. The next step is solving, where equations and repeating iterations take place. And finally, the post-processing step, where the solution is analyzed and visualized to be displayed.
مظبوط. شغال. من أكبر المشاكل اللي بتواجهنا حاليا هي مشكلة نقص الطاقة، بالإضافة للتلوث والكوارث البيئية الناتجة عن استخدام الوقود الأحفوري في توليد الطاقة. من خلال دراستنا في قسم هندسة القوى الميكانيكية كان هدفنا أثناء اختيار مشروع التخرج إننا نساعد في حل المشكلة دي، وعشان كده اتجهنا لمصادر الطاقة المتجددة وبالتحديد طاقة الرياح. طاقة الرياح بتتميز عن غيرها من مصادر الطاقة المتجددة بإنها بتكون متوفرة على مدار اليوم في أوقات السنة المختلفة. فكرة تربينة أرشميدس كانت الأنسب لينا، وده لأنها بتتميز بوزنها الخفيف وحجمها الصغير، ده غير قدرتها على العمل في سرعات رياح منخفضة. وخلال 6 شهور متواصلة من العمل قدرنا ننفذ تصميم التربينة وطبعناها وعملنا عليها التجارب المعملية والدراسة النظرية اللازمة لضمان كفاءتها، وده كان بالاستعانة بالأبحاث العلمية وبمساعدة وإشراف أساتذة ومعيدين القسم. وأثناء الشغل كان تركيزنا على حفظ وتسجيل كل النتائج والبيانات والمعلومات اللي وصلنا لها، عشان اللي هيكمل ورانا في المشروع يقدر يلاقي مصادر تساعده. وفي النهاية بنتمنى إن المشروع يتنفذ فعلا على أرض الواقع ويكون لمصر دور في حل مشكلة الطاقة العالمية.